In front of us we have a Rosemount 44 TJ thermocouple transmitter. It's an analog transmitter. It takes the input of a type J thermocouple that we have right here in our ice bath and converts the signal to a 4 to 20 milliamp signal. So the first step here, what we want to do, we're eventually going to need our Fluke 9100S, 9100S dry block calibrator. We want to turn it on and set it for 100 degrees C, so it's good and warmed up before we need it. The type of calibration we're going to be doing here is what is called the ice bath method, and it's where we put the thermocouple in an ice bath here and wire it up as shown here. We need to have a millivolt source. The millivolt source in our case is going to be our Fluke 725 multi-function process calibrator. So I have that connected up. So you can see here the positive of the meter goes to the positive of the millivolt input on the transmitter, and the negative of the millivolt input, or the thermocouple input on the transmitter, goes to the negative lead on the thermocouple down to the ice bath, and then the positive of the thermocouple goes to the negative input on the millivolt source. So let's just see over here. You can see how I have the positive, this red here, alligator clip is connected to the positive. You can see the thermocouple diagram here on the transmitter. The red alligator clip is connected to the positive there, and then goes back over here to our meter right here where we can source a millivolt value out. The negative side of our meter here, this black lead, is connected to the positive lead on our thermocouple. So thermocouples are kind of an anomaly. They have the red lead on a thermocouple is always negative, and then the other color, the identifier of the thermocouple, this is the type J, it's white, is the other color. So red is always the negative lead on a thermocouple. The output here, which is these two terminals right here, they're broken out down here on this board here for quick connect. This is where we're going to be connecting our 24 volts source, and we're also going to be connecting the milliamp side of our calibrator here, so we can read a milliamp value from our transmitter in series. So you can see we've got the loop here is completed by, we start over here at our 24 volt power source. This lead goes out, goes over to the milliamp input on our meter, out of the milliamp input of our meter, and into the positive lead on our transmitter. Then from the negative lead of our transmitter, it goes back over to the negative lead of our power supply. So we have this guy here hooked in series with the 24 volts and the milliamp output of our transmitter. So it's all connected up. What we need to do when we're doing this calibration is need to make sure that we're agitating the ice bath here, because you can already see our milliamp value is dropping. So you want to keep that agitated as we're doing the calibration. The first step here is we're going to be sourcing 0 millivolts. You can see on the bottom side here we're sourcing 0 millivolts. Up here we're measuring the 4 to 20 milliamp signal, the current signal output of the transmitter. So to toggle the top screen here, use this button right here. You can see it toggles between milliamps and volts. And to get the bottom side here to source, we press this measure source button. You'll see it switches between measure and source. So we want it to be set to source, and then we use this voltage milliamp button here to toggle till it reads millivolts like it is right now. So right now, if we are sourcing with the ice bath method here, as long as we're agitating our ice bath and we're sourcing 0 millivolts, then our transmitter should be reading 4 milliamps. So to make that adjustment here, we would then go to the top side of our transmitter here and adjust this 0 screw here until this reads 4 milliamps. So to do our span, or to set it for 20 milliamps, we're going to be adjusting the span setting here. The next thing that we need to figure out how to do is to figure out what voltage here to source to represent our span. So we're going to be calibrating this for a 0 to 100 degree input. We need the thermocouple table over here. You can see, looking at the thermocouple table, this is for the type J thermocouple that we're dealing with here. If we look, the value for 0 degrees C, following the table down, for 0 degrees C is 0 millivolts. So you can see the table over here is in thermoelectric voltage in millivolts right there. So 0, and that's what we're doing right now for our 0. Since we want to calibrate this for 0 to 100 degrees, we need to find 100 degrees, which is right here. So the value we need to input is 5.269 millivolts. If we were doing 101, it would be 5.323. If we're doing 102, it would be 5.378, and so on. So these go up in an increment of 1 degree. So this is the value we're going to source. It'll be 5.27 actually, because our millivolt meter only goes, it only has 2 decimal places here, you can see. So let's input that 5.27. 5.2, oops, sorry, 5.27. So you've inputted a value of 5.27. I'm just going to agitate the ice bath here. And you can see also we would want to do a little bit of a span adjustment there to make our meter up here read the 20 milliamps that it's supposed to. So make sure we're agitating this ice bath over here when we're making our adjustments, and calibrate our transmitter to 0 to 100 degrees C with a 4 to 20 milliamp output. All right, so now I've removed the the millivolt value, millivolt input into our transmitter, and connected the thermocouple directly to the transmitter here, the white lead going to the positive, red lead going to the negative of the type J thermocouple. This wiring then flows out of our transmitter into this thermocouple connector, and then the measuring junction of the thermocouple is down here in the ice bath. So with me agitating this now at 0 degrees C, this ice bath should be at 0 degrees C. Our transmitter is reading pretty close to the 4 milliamps. We calibrated at 4. The next step here is going to be, we're going to insert the thermocouple into our dry block here just to verify our calibration. All right, so now we place the thermocouple in the dry block here. It's at 100.1 degrees C. And over here, you can see our transmitter is pretty close to 20 milliamps. It's at 19.815. Thermocouple, the type J thermocouple right here. You can see if we're dealing with standard here, the limits of the error is going to be plus or minus 2.2 degrees C here. So that equates to about 0.35 milliamps roughly in our range. And so we're within 0.2, so we're within that range. We're good to go on to the next step. Right, so in the next step of the lab here, we're going to be we're going to be needing a temperature of 125 degrees C. So we're going to change this. Right now it's set for 75, you can see, but I'm going to change this by pressing set and toggle till we get a screen that says something like this, where it has a value 1, 2, 3, or 4. This is a stored value of 75. We want to modify that, so we'll select the value we want to modify. So select that, we'll press set, and then we will change the value. So we want to go up to 125 degrees C, so I'll increase this value to that. Press the set button until we are back to the screen where it displays Celsius value right here. And so now this value should start to increase. The dry block will start to heat up. All right, so this time around we're going to be using a thermocouple calibrator. This is a device that's designed for calibrating thermocouples. It's specifically only for thermocouples, whereas our meter over here, it can do more than just thermocouples. It can do RTDs, and it can be used for measuring current, measuring voltage, sourcing current. So it has a broader application here, whereas here this is specifically for thermocouples only. So what we're going to do is we're going to power this on by pushing this button up, and the next step is going to be, it's going to ask us to double click this knob. So now to calibrate our transmitter, we're calibrating it for a range of 0 to 125 degrees C. I've disconnected the thermocouple here. We want to make sure we have it open here because we're going to be connecting our leads of our thermocouple calibrator. We're going to use the thermocouple calibrator now to calibrate it. We're going to be connecting across the positive and negative leads here. These wires can stay on. We're going to be reading our milliamp value over here right now. It's overload right now. It's open loop because we have the thermocouple disconnected. So we're still using this to read the milliamp value, but now we're using this to source our millivoltage of the thermocouple. So right now it's set for 0. Nice feature here is it has a low and a high setting for when we're doing a calibration. So to do the high setting, we'll go up you can see it automatically goes to 125 as well. So if we wanted to change this to say 126, we could change it. As long as we have this switch up to the high setting, we press this button here, it will store that value. So now you can see if I can go down to the low, it's at 0, we've set it for 0, and I can go back up, and now it's storing, it's opening a value of 126 degrees C. So we need to be set for type J. To do that, so we'll go back to the set, to the middle switch here, press this button once. Yeah, double, we have to press it 2 times, and then now we can make changes here. We can change the units, we can change the type of thermocouple, that needs to be set for type J, and we also want to have the cold junction compensation set on here. And what that does is it measures the ambient room temperature, because the thermocouple has a reference junction right here, and then also the at the end here, the measure junction. So there's 2 junctions, and this junction, the reference junction, is going to generate a millivolt value that's going to oppose the millivolt value of the measure junction here. So this is going to compensate for that. The reason why we had the thermocouple in series in the last part was for that same reason, was to compensate for that reference junction. We were creating a reference junction and then putting it at 0 degrees C, because that's what these tables here are a reference to, the thermocouple voltage at 0 degrees C. So we needed to get that reference junction. We need to get that reference junction to 0 degrees C, and that's why we placed it in the ice bath. So back over here, once we have the values that we want to calibrate this for, now we can go low for 0 degrees C and high for 126. We'll back that back to 125. Hold this down. It'll store the value. Another feature too, if we need to make big changes, if we push on the knob, it'll move around a lot more rather than not pushing on the knob. You can see it doesn't move the temperature as much. So let's set that to 125. Now we're going to just be taking our leads here and placing them across red to the positive, black to the negative right there, across where our thermocouple would go to source our millivolt value in. And you can see over here our transmitter is reading pretty close to 20 milliamps at 125. So I've already calibrated this transmitter. And then just to confirm here, you can see if I pull these leads out, that there, the red is indeed hooked to the positive. So just because of the color coding confusion of the thermocouple having a red negative lead, we want to make sure that I wanted to clarify that. So in the next part of this lab, we're going to be removing this cover right here for the thermocouple connector to expose the wire junction here. And we just have to take out these screws. Because what we're going to need to do, we need to access this, because we're going to be cooling this junction with either a cold air gun or a bag of ice to drop the temperature here. We want to see what it does to our milliamp value over here on our fluke. So we're going to do it there, and then in the next step we're going to be removing this and placing these copper extension wires in the loop here. So this is going to plug in over here, and then our thermocouple is going to plug in to the end over here. So out in the field, what can happen is if we need to extend these lines to get to a temperature measurement that's quite a bit further away from the transmitter, a common mistake is to use copper wire. So what we want to see is what happens when we cool this junction versus this junction. So we want to make sure we cool this one junction first, then install the copper extension wires and cool this junction and see how it affects our milliamp reading right here. All right, so in the last part of this lab, we're switching over to the Rosemount 644. This is a smart transmitter. It has the thermocouple tables and everything stored in it. So we've wired in a type J thermocouple here. You can see across terminals 2 and 3 right here. It shows over here in the diagram for a thermocouple plus minus. Red being the minus again, or the negative lead. We have a 250 ohm resistor here connected in series with our power supply, which runs down to our 24 volts right here, and then our 0 volts, or sorry, not our 0 volts, well, it should be 0, I guess, negative volts, negative 24 volt back over to our power supply there. So we've got a loop connected there. We've also got our Trex communicator here. This is to communicate with the smart device so we can make changes and stuff to it. across these two hook leads right here, which then go into the top of the communicator over here. On this side here, you can see we're in the heart side. That's the communication protocol that we use to communicate with the device. There's some other leads here with heart power. You can measure current, stuff for another protocol called foundation field bus. We're going to be connected over here on this side. We've got it powered on here. There's just a power button over on the side. We've got it powered on. I've got power, green lights illuminated here. We've got power, 24 volts going to our transmitter. So if we just click on the field communicator right here, it should open up and try to talk to our device. So I want to stress the importance of this 250 ohm resistor here. It's a requirement for heart protocol to be in the loop. So it can talk. If it's not there, you won't be able to talk to the device. So it's just connecting to the device right now. And what we're going to want to do is we're going to want to configure the device. So we're going to click on the configure button down here, and then go to manual setup, and we want to change the sensor right here. So we'll click on the sensor, and right now it's an ohm type. We want to change it to a thermocouple, so we should be able to edit this. And we want to find a type J thermocouple here. Let's see if it has our type J in here. Down here, type J, so we select type J, click OK. It's 2-wire, so click OK. And then now, if we go back to the overview screen here, this should have changed. Let's just go back. Oh, maybe we didn't send our changes here. Let's just go back to configure. It's type J, yes. Let's click the send button here. So let's send our changes out to the device. Unit 4 to 20 milliamp set to new sensor limits, click OK. So what that's saying is the 4 to 20 milliamp output is set to the sensor limits, which is like a really large number. We'll probably see it right here. Yes, minus 180 degrees C to positive 760. So that's what the 4 to 20 milliamp signal is set to. You can see right now it's measuring room temperature right around 21.4 degrees C. And so what we're going to want to do here as well is we're going to verify. We're not going to do calibration here. We're just going to verify that the transmitter is working correctly by inserting the thermocouple into a ice bath and also into our dry block at either 100 or 125 degrees C. And we should see the temperature change here to the right value to verify it. Should be able to verify within at least about 2 degrees Celsius.